This lesson is about the normal distribution. And basically, a normal distribution is a continuous probability distribution for a random variable x. The graph of normal distribution is called the normal curve. Sometimes we hear it called the bell curve. And normal distribution has following properties. Before we go there, a normal distribution basically looks like this. We use it a lot when we want to normalize data. A lot of days we like to normalize our test scores, ACT, SATs, those kind of scores are normalized. It compares you to everyone else. The middle number is called to be the mean. So you might see the mean as x bar, or you may see the mean written as mu. Mu would be a population mean, and then x bar would be a sample mean. So they both represent the same thing. Well, they both look the same, but one represents the entire population and one represents a subset in that population. We usually use x bar. Rarely do we have the whole population, but sometimes we do. So anyways, that's what it looks like, and it basically compares your score to the average. Basically, it says most people are about average, or most things are somewhere near the average. And then we have other things that are further away from the average. We call those things, we measure that distance by its standard deviation away from average. So this would be one standard deviation, right? That's a symbol for standard deviation, is lowercase sigma. And this would be two standard deviations. And then we can have one that's three standard deviations. It's very rare to be three standard deviations. If you're outside three standard deviations, we call that space an outlier. Outliers are outside of three standard deviations. So anything outside two standard deviations is considered an outlier. I'm sorry, three standard deviations is considered an outlier. On the back end, we have a standard deviation too. So this is -1 standard deviation. It's -2 standard deviations. It's -3 standard deviations. So again, on this side, outside of -3, is also an outlier. But basically, this basically says most people are lumped somewhere within, the majority of people should be lumped somewhere within one standard deviation of the mean. And we're going to talk about percentages there in this moment, but that's what a normal curve is, and that's what this lesson is all about. All right, so basically, a normal distribution has the following properties. You have a mean, a median, and a mode, and they're all equal. If it's a normal distribution, the mean, median, and mode are the same. If it's not normal, it's skewed. This data is skewed right. So this is skewed right. Mainly because the mean is here, but the mode is somewhere around here because most people are around there. The mean is higher than the mode. Mainly because you got some place over here, someone, maybe this is salaries of professional basketball players. And most professional basketball players' salary is probably around $8 million a year. But you have some players who make $100 million or $70 million. So because you got those few players, LeBron James, Steph Curry, and so forth, they have these huge salaries, it'll shift the mean, and the data may say the mean is $20 million a year. But truth be told, the mode is somewhere near 8, so most people make somewhere near $8 million a year. But because we have someone skewing our data, our curve looks skewed. So we say this is skewed right, as in someone's on the right skewing our data. So in this case, the mean, median, and mode are not the same number. But if it's normal, the mean, median, and mode are the same number. They're right there in the middle. And that's skewed right. And another graph could look like this, where our mean is right here, and our mode is someplace around there. This is our mode, where most people are there, but our mean is far away from it. So this is said to be skewed as well. It's skewed left. Because this could represent, a good example of this one could be test scores. I may give a test, and most people probably score somewhere around 85. But you got someone who didn't show up for the test, and you may have gotten a 15. Or maybe showed up and you got a 0. So those people who had these really low scores, Instead of my mean being somewhere near 85, where most scores are, my mean is below it. Maybe my mean is now 60. And it looks like the average score is 60, but it doesn't truly tell the story of what's happening, because most people score someplace higher than that. So those data are skewed. We talk about those kind of charts as well. In those cases, the mean, median, mode aren't the same. All right, so anyway, the next part is the normal bell curve is shaped and is symmetric about the mean. So if it's normal, it's symmetric about the mean, as in it looks a mirror image about the mean, about a mirror image. The total area underneath the curve is always 1, so A equals 1. And the symbol for this is x is about normal. You know, x is about normal, and they may give you that the first number is your mean, and the next number is your standard deviation. So sometimes you see it formatted this way. It's telling you it's a normal curve where you have a mean and standard deviation. But anyway, the area beneath is about 1, and the normal curve approaches but never touches the x-axis. So it's asymptotes. So it's an asymptote to the x-axis. It's closer and closer to it, but never actually crosses it or touches it. All right, empirical rule. That's what we're going to spend most of our time on. We're going to spend most of our time talking about the empirical rule, which is really nice. The empirical rule basically says this. It basically says that in a normal distribution with a mean of x bar and a standard deviation of sigma, you can approximate areas underneath the curve as the following. That 68% of the area in between the mean and then take away a standard deviation and the mean plus 1 standard deviation. What that means is this. If there's 68% of data between the mean, so this number in the middle would be your mean, this would be x bar or mu, and this would be x bar plus 1 standard deviation. This would be x bar plus 2 standard deviations, and x bar plus 3 standard deviations. And this would be x bar take away 1, and x bar take away 2 standard deviations, x bar take away 3 standard deviations. All right, and keep in mind, within 1 standard deviation, as in 1 to the left or 1 to the right, you should have 34% here and 34% there, give you a total of 68% of all data in that first standard deviation away from the mean. And then empirical rule also says that 95% of all your data is within 2 standard deviations to the left or right of the mean. So this is within 2 standard deviations of left or right. So here to here. So look at this. So within 2 standard deviations of the mean, there's 95% of all your data. So let's think about this. If you got 95% of all your data between 2 standard deviations, and 68% is already accounted for. Well, that leaves you about 27% left, and that goes here and here. That leaves you with 13.5% here and 13.5% there. So that's why we have 95% of all our data within 2 standard deviations of the mean. Outside 2 standard deviations, we call that data exceptional. We use the word statistics exceptional only if you fall outside 2 standard deviations of the mean. And also here, if you're outside 3 standard deviations, again, we call that an outlier. They're very exceptional. They're so exceptional, they have their own name as well. They're outliers. They are very different from the norm. They're outside 3 standard deviations of the mean. So just continuing that, there's 99.7% of all your data in between 3 standard deviations. So if I go between 3 standard deviations of the mean, I've got 99.7% of all my data, leaving only 0.15% on the upper end and 0.15% on the lower end of all your data. Anyway, so that's what empirical rule is, and that's what the normal curve talks about. All right, here's another example. So example 1, remembering the normal distribution has a mean and a standard deviation of sigma. Find the indicated probability that a randomly selected x value from the distribution will fall here. This basically reads the probability of x being between the mean and 3 standard deviations. I'm going to draw a picture of that. Every time I'm going to draw a picture. So draw this curve every time. So here's my mean. And here is my mean plus 3 standard deviations. It's saying find a probability that your data will fall in that range. So we got to think about what are the values in that range. So all right. So basically, in order to answer this, we have to know what percentage of data is in between there, and then we can find that probability. So basically, let's remember this. This is the normal. This is the empirical rule. If that's normally distributed, then this is the mean, and then this would be the mean plus 1 standard deviation. And then this would be the mean plus 2 standard deviations. And this would be the mean plus 3 standard deviations. So if I want to know the area between that curve from 1 to 3, I want to know the percentages here. So basically what we're going to do is we're going to add up 34% plus 13.5% plus 2.35%. And if you add those, well, it adds up to be 49.85%. So that probability is a 49.85% chance of that actually happening. We like to write probability as a decimal though, so we can call that 0.4985. This is written as a percent, but generally we like probability written as a decimal. So the first question asks, what's the probability of choosing data between there? And that is 0.4985. Or if you said 49.85%, no one would be upset about that. Go to the next one, but I want this. Next says, what's the probability of x being greater than the mean plus 2 standard deviations? So that's probability of x being greater than the mean plus 2 standard deviations. Let's go back to that curve. So this is the mean plus 2 standard deviations here, and that means outside this range. So that answer would be 2.35% plus 0.15%. So that would give you 2.5%. And as a decimal, 2.5% is 0.025. So probability is 0.025 or 2.5%. All right, so that's what that is. Example 2 says, on a box of cereal, the weight is listed as 12 ounces. Among all the boxes of cereal of this type, however, the actual weights approximate a normal distribution, which with a mean of 12 ounces and a standard deviation of 0.1 ounces. So before we begin, we got to draw that picture. And that picture would look like this. So the mean is supposed to be 12 ounces. So we put 12 as the middle. It said normally the standard deviation is 0.1 ounce. So it's going to be 12.1. And then 2 standard deviation is 12.2. Then 3 standard deviation is 12.3. Now on the back end, I'm going to take away 0.1. So it's going to be 11.9, 11.8, and 11.7. This is my mean. So this is the normal curve. So you have to do this every time before you start the problem. It says, what is the probability that the contents of a randomly selected box of cereal of this type is within 0.1 ounces of 12 ounces? So it's basically saying within 1 standard deviation. That's what the standard deviation is. So this is 1 ounce on the left, and this is 1 ounce on the right. If you remember, it's 34% here and 34% here. So it gives you a 68% chance of selecting the cereal that is within 0.1 ounce, 12 ounces. So you can call it 68%, or as a decimal is 0.68. right, give you one last example. And that's actually over my 15-minute mark. I like to keep them under 15 minutes. But if you want a practice example, here's a new one. And yeah, we can talk about it in class, but that's my last example. That's all I have. Good luck.